Welcome you all guys to debugging doubts. Now I will tell you how to solve push-down automata. So here this is the definition of push-down automata, that is m is equal to q sigma gamma delta q naught z naught and f. So q is the finite number of states like q1 q2 q3 something, and sigma is the input alphabet, and this gamma is the stack alphabet, and delta is the transition function like we used to do in NFA DFA, right? Same thing. Q naught is the initial state and Z naught is the initial stack symbol. F is the set of final accepting states. So in order we are using a stack, so in order to push and pop we use this type of transition definition. So for push we use P A Z and that gives Q and AZ. So what does it mean? So P is the initial state and Q is the next state. So A is the input variable and Z is the top of the stack. So when we encounter A and top of the stack, we are defining what should be done. So here we are pushing, so A should be pushed to Z, so it will become AZ in the top of the stack. So this is also top of stack. Okay, so here you can see pop now. So same thing, P is the initial state and Q is the next state. So we are getting a value as A and top of the stack is Z. So what we need to do, we need to pop it. So what we do, when we encounter A, we are popping Z, so that will be replaced by epsilon. So you will understand more in the when I solve this question. So let's take an example. Let's suppose there is a word that is W and then we write a C and then reverse the word. So word can be in the set of A plus B whole star. A plus B means A or B and star means any number of time it can be repeated. So my word can be A B or A B or A something, anything it might be in the A and B. So now what I am doing is I need to find whether this string matches, that is like looking like palindrome, right? So one is word, then C, then another reverse word. So what I do is first I will fill the stack with all the words I am getting with W, and then when I encounter C, I start popping all the elements from the stack in the same order. So if it satisfies, then my push down automata works and the word is matching. So for that I'll write the transition steps. So these are the transition steps. So first I'll be in the Q naught state and I encounter A when the top of the stack is Z. You need to understand in this way. So top of the stack is Z naught, I'm getting A. So what my next state will be, I'm pushing all the values, right? Until I get C, I'm pushing. So I'll write it as Q naught comma A Z naught. And then if I get B, then also I push. Whatever may be on the top of the stack, I'm just pushing it. So I wrote in this way. Then if I'm getting A and already there is A on the top of stack, then also I'll push A. So Q naught, I need to write all the possibilities. So Q naught, when it is A and top of the stack is B, then also push. So A, B. Then here Q naught, B, A, and here Q naught, B, B. So this is how I write. Suppose then suddenly there is a C and I'm top of the stack is Z naught. So you try to analyze all the combination. So when there is a C and there is a top of the stack is Z naught or A or B, anything it might be. So what I should do, I should change my state. So I should change my state. So in the other state I'll define in some other way. So what I do is Q1 and this C will do nothing. I'm just replacing Z by Z naught only. So I'm just replacing it. So when I'm getting C and there is A on the top of stack, then just change the state, do nothing. So keep it as A, top of the stack. Then Q naught and this is C and top of the stack is B, then do nothing. So keep this as same, only change the state this way. Now I have filled my stack. Then when I get C, I am changing my state. Now what I should do, I should remove each element when I get the same element only. Like if I get B, I should remove B only, and if I get A, then I should remove A only. And if I get B and top of the stack is A, then this fails. So I need to do only for this thing. So I return when I get A and top of stack is A, then what I should do, I should remain in the same state, but I should remove A, so I write it as epsilon, top of the stack. Then if I get B, then I remain same state and just replace by epsilon. And if I'm having the epsilon, see, this is the final one. If I'm getting epsilon and there top of the stack is z0 is initial, right? So my stack is really empty. So what I should do, my stack is empty, I need to go to my final state. So what I do, I write it as q2, change the state, and z0 keep it is as it is. So this is how we written all the transition steps. Now I need to construct a this thing diagram. For that thing I refer this. So what I do, I have only three states, that is q0, q1 and q2. So you can see when I'm in q0, I'm going to q0. So these are all self loops. You can see q0 to q0, q0 to q0. So what I do, I write it as self loop, and here I write a comma z0 is giving a z0. So a comma z0 giving a z0. Then b comma z0 gives b z0. All the values I need to write. A comma a gives a comma b gives a comma c a, b comma a gives b a, and b comma b gives b and b. So these are written. Then you can see if I'm in q0, I'm going to q1. When I get c, so this thing I need to write q0 to q1, so that when I get c comma z0, I go to z0 and replace by z0, sorry. Then c comma a, I replace by a only, and c comma b, I replace by b only. So this is how I written. Then when I'm in q1, you can see q1 to q1 there are only two states, so I write it as self loop. So when I get a and there is already a, I make it as empty, and I get b and there is already b, I make it as empty. And you can see q1 to q1 there is only one state, so I write it here. So when I get epsilon and there is z0, I replace by z0, and this is my final state, so I write it as this way. So this is how we can complete a diagram and also the transition steps. This considers more marks. Now I will test with some example. Suppose my w is a b. Okay, so I will create a string, okay, from this you can see. So I will write it as example. So w is a b, right? So a b, then what should I consider? C, and then what I should do, reverse the word, so that is b a, this way. So now I will start my delta function. So first thing, write delta, then q0 comma the string same w, so that is a b c b a, okay, and comma, so initial stack symbol z0, and that gives what it gives. So first I consider a. So when I'm getting a and there is z0, where I have defined a and z0, what should I do? I should push. So I write q0 a b c and b a comma a z0. So I pushed here. Then I do second transition. So when I get a, I should again push. When there is a, I defined here. When there is a and a, I should push a. So it will become q0 comma a b c b a comma a z0, this way. Then once again q0, I am getting b. So when I get b and there is a and I am in q0, so what I should do? I should push once again. So I'll write c b a and b a z0. Then when I get c, so what should I do? So when I get c, you can see when I get c and top of the stack is, you can see top of the stack is b here, right? So where it defines when I get c and top of the stack is b and I'm in q0, I should just do q1 and replace by b. So what I do is I just make it q1, and this I'll keep it as v only, then write the remaining terms, then q1, and I'm getting b. So in q1 if I get b, where I define q1 I'm getting b, and there is already b in the top of the stack, then I should eliminate it. So I'll write AA, and this B I'll eliminate here, so it will become AA Z0. And same thing, Q1, when there is A and there is A in the top of the stack, I should eliminate it, that will become A Z0. And here Q1, so AA, so A also eliminated, and there is epsilon, and here also it will be Z0. Now when I reach this, you can see I had defined this earlier. So when I am getting Q0 and epsilon and Z0, then I should replace by Q2 and Z0. So that thing I will do finally, Q2 and Z0. So I reach my final state, you can see. So the string is verified. So this is how you can use push-down automata and solve this problem. So thank you all guys for watching, and if you like my videos, please like it, share it and subscribe it. Thank you all guys.